Raptor Lake. Raptor. We just on the same page. We do know that that wasn't a Velociraptor, right? That was a Deinonychus that Spielberg decided to call a Velociraptor because Hollywood. I don't know, doesn't matter, not important. What does matter is our sponsor. There's no sponsor. Although, mate, Chris, sorry. Yeah, Chris, mate, I know you're busy. I don't know if you got my email or the 30 that I sent. They keep bouncing, but mate, could you just press the subscribe button, please, mate? You keep I keep seeing you coming and going, but you don't press it. But it's just down there, mate. Thanks in advance. So today, Intel are fighting back against AMD's recent Zen 4 launch with the arrival of their new 13th generation core platform. 12th gen was a huge leap forward and a paradigm shift in how CPUs operate. So is this next generation going to reproduce last year's success and progress? Or are we basically seeing 12th gen Pro Plus? Well, either way, today Intel are opening the box on their flagship Core i9 13900K and the Core i5 13600K. We're going to get an i7 a little later. Didn't get sent out to us, but is this all worth considering if you're looking to upgrade your system now? Is this something you should think about? Well, it's an easy question, mate, with a complicated answer, and it's going to be mostly to do with the thing the entire media scene is by now probably making a huge fuss of in a song and dance. The power consumption. It's a lot. I mean, it can be a lot. I do mean a lot. However, though, because I focus on professional applications here, sorry if you're looking for gaming tests, you're at the wrong place. You have to bounce over to another channel for games and stuff. But the power draw that you'll soon see could both potentially be a big issue and potentially a complete non-issue, maybe for reasons that aren't immediately obvious, but more on that later. So, if you haven't seen any of the coverage already, mate, the i9 13900K is a 24-core part with 32 threads. Mate, 24 cores! Let's not forget, let's put that into perspective. Last year's 11th gen i9, the 11900K, now that was only last year, had 8 cores. This brings 8 performance cores, which is the same as the 12900K, but it increases the efficient core count from 8 to 16, giving us 24. Clock frequencies as well have seen a massive bump to a screaming 5.8 gigahertz on a single core, with an all-performance core boost of around 5.5 gigahertz. And then 4.3 gigahertz on the 16 efficient cores, which is just absolutely mental. We're also getting a not so insignificant increase in cache with 36 megs of L3 smart cache and 32 megs of L2 cache, which equates to about 2 megs per P core and about 4 megs per E core cluster. Intel also states that the processor base power is 125 watts with a turbo rating of around 253 watts. But as you'll soon see, that's that and the 3 gigahertz base clock, mate. Let's just say it's more of a guide. It's a hint. So this is the spec of the test bench that I've used for all my testing. 13th gen does bring along with it a brand new chipset platform called Z790, which increases the chipset PCI Express support to Gen 4, along with native support for USB 3.2 Gen 2. But you'll see here that I've got a Z690 board instead of a Z790 for testing, which is absolutely fine, and it's 100% supported. You don't need a Z790 for any performance gains. And for cooling, I've got a 360mm liquid AIO cooler, which was used for the i9 testing, but to keep things fairly realistic, I've also got a 240mm AIO from Cooler Master, which was used for the i5 testing. So for the i9 13900K, mate, this is the peak core frequency plot during a 2-minute Cinebench R23 all-core workload on loop. No BIOS changes to the stock MSI BIOS, no software mods, no tuning, no overclocking, basically out the box, mate, and we're seeing expected single-core boosts to 5.8 gigahertz before the test even begins, which is to be expected. No sign of that 3 gigahertz base clock though. And then a massively impressive, exceptionally stable 5.5 gigahertz frequency across all the 8 P cores throughout the test, with those periodic spikes there being when Cinebench was cycling over to start the next test in the 2-minute loop. Now for the E core frequencies, I don't think I've ever seen a more stable plot than this. All 16 E cores steadily maintaining their near 4.3 GHz frequency throughout the entire duration, but changes to the power plans and C states along with differing implementations from various motherboard vendors or system vendors should see all of these frequencies dip and rise more reactively to workloads, but this was out of the box experience that you're going to get with an MSI Z690 motherboard. This one's the Force Wi-Fi. Performing the same test with the i5 13600K sees more deviation in P-core frequencies, bouncing between 4.8 to the 5.1 GHz boost under load, with E-core frequencies mostly remaining 3.9 GHz, but occasionally dipping to 3.8 GHz. Now, when you've effectively got over 100 GHz happening inside a relatively tiny CPU tin lid, things are going to get pretty toasty, mate. However, when the system's idle or during pretty low intensity nondescript tasks, the i9 3900K sits at a fairly chilly and respectable 30 to 40 degrees C, with it rising to an expected 99 to 100 C under the full load of a Cinebench test, and a similar trend is then seen as well with the i5, which idles around 30 to 40 and highs of 100 C. As for power consumption, mate, well, to be fair, at idle, the 3900K consumes a very conservative and respectable, efficient 3 to 15 watts of power whilst nothing much is going on, again, under low intensity tasks. But this is a big but. Biggest but I ever done so. The second you hit the i9 with an all-core workload, well, so much for 253 watts, power consumption jumps to an insane 345 watts of sustained power draw throughout the test. And I did see this rise to around 375 watts after I installed all the MSI motherboard software later on, which then manipulates all the power profiles and the frequencies. The i5 is equally as power hungry on the MSI board, peaking at around 219 watts and averaging out at around 210. That's not far off, mate. Last year's 12900K peak power draw of 240 watts on an i5. That's a lot. So after seeing this, mate, I had some thoughts. I had a lot of thoughts. I had questions, chief amongst those being, well, what if you don't have a 360mm Goliath liquid cooler to use with the i9? Well, the next best thing that I had was that 240mm liquid cooler from Cooler Master that I was using for the i5. And Christ, mate, does this raise some questions? So using the 240mm cooler with the i9 under the same load as before, so the P-core frequencies failed to hit the 5.5 GHz under load. Instead, they were bouncing between 5.1 to 5.3. And that's going to obviously peg back the potential performance of the i9 3900K to varying levels. You're going to lose a lot of performance based on what cooler you've got. Same story as well with the E-cores. Whilst we saw a flat line of 4.3 GHz previously with all those E-cores, well, now they're all over the place, mate, averaging out between 4.1 and 4.2 GHz. Expectedly, temperatures are around the same range, hitting 100 C pretty quickly whilst dialing back the frequencies and the power draw to ensure that all those things don't tumble out of control. But here's the end result of all of that, mate. Under the 240mm cooler, the 3900K just wasn't able to pull its maximum power draw, so instead dialed itself back to pulling around 330 watts peak, but then averaging out to around 290 watts under sustained load. It's a full 50 watts lower than its maximum potential. Performance is going to suffer because of that. As for the actual performance of the parts, mate, first off, before I show you them, I don't have any of the new AMD 7000 CPUs because reasons. So what I've had to do is grab some results from some other well-known reviewers who've already reviewed these parts. So the comparisons that you're about to see are far from done in a controlled environment, but they should be close enough. So under the 360mm cooler, the Cinebench score for the i9 3900K puts it at 4368, which is ahead of the Ryzen 7950X. But it does have to be said, mate, that the Ryzen part achieves that performance with a significantly lower power consumption. But looking at the gen over gen performance, mate, that's a 48% gain over the outgoing 12900K. The i5 lands on 23992, which is seriously strong, mate, for an i5. It demolishes the more expensive Ryzen 7700X and also the slightly cheaper 7600X, but it can't be ignored that the i5 pulls significantly more power. The Cinebench single-threaded scores, mate, firmly place the 3900K at the top with a 9% lead over the 7950X, as well as being giving a typically standard gen over gen gain of 21% over the 12900K. The i5 on the other hand, still decent at 1994, but nowhere near 3900K, and then nowhere near as well the parity that we saw between the i5 and the i9 at single-threaded performance when 12th gen launched last year. They were both the same pretty much at single-threaded workloads. Not this year. The much underrated InvMark for Autodesk Inventor bench test sees the 3900K position itself yet again at the top with an insane score of 78,229. It's a 15% gain from the 12900K at stock, but mate, expect to see that number rise well over 80,000 once end users apply overclocks and faster memory profiles to the 3900K. The 7950X at stock lands around 72,000, rising to the region of around 77,000 once the users start tuning and tweaking it. With the 12900K scores, again, they were massively varied, anywhere between mid-60s up to 76,000 with high overclocks. The i5 though came in with a very respectable 70,909, which is higher than last year's stock i9 12900K. Whilst still exceptionally capable at 3D CAD workflows, I would say the i9 reigns supreme for most Autodesk workloads. In the Blender 3.3.0 test, the i9 does impressively well here, with the i5 sitting way down where you'd expect it to be. But mate, I don't have anything close to as much historical data as I'd like for this Blender test, just due to being a lack of information out there. So feel free to do call on your own results and experiences and research when comparing against these. As much as I'm not a fan of 7-zip tests as well, mate, everyone else seems to use them and show them. So here you go. AMD seems to be able to zip up files faster. Cool. The Catalyst OrCAD CPU index test is next. Again, not sure of the relevance of this because it's a pretty old test. Doesn't test much in the way of or a variety of modern functions that AutoCAD has, but I know I've got historical data for it, so here you go. Predictably, the 3900K lands on top with a 15% lead over the 12900K, with the i5 trading blows with last year's 12900K. So good scores all around. A fairly modest 11% gains had in the Revit modeling test, putting the i9 3900K at almost 50 seconds, which is astonishingly close to being nearly twice as fast as the flagship 10900K from only 2 years ago. Similarly impressive is that i5, mate, because that goes sub 60 seconds as well, ahead of the 12900K. Good for Revit, that is, mate. The feat, though, of being twice as fast as the 10900K was achieved in the Revit graphics test, with the 3900K finishing things up in only 14 seconds, with that 10900K sitting at 29 seconds. The i5 again doing remarkably well, sitting between the 12th and 13th gen i9s. And by the way, mate, all of these other CPUs in the chart here they're all there purely for contextual reference, because again, there's bugger all out there for CAD applications and tests and many online scores published. The V-Ray CPU rendering test was seeing a gain of 47% over the 12900K for the 3900K, whilst pulling around 40% more power though, which it's almost like a linear scale. Again, as I said at the start, I didn't run this 7950X score, so whilst I've got no reason to doubt its validity, it doesn't quite fall in line with the Cinebench scores between the 7950X and the 3900K, but it is what it is. CPU rendering on Keyshot again puts the 3900K on top, with yet again there being no way to reference scores from other CPUs due to complete lack of any online leaderboard or area for publishing results. But 5.7 for the 3900K over the 12900K's 4.72 is still an impressive gain for CPU rendering on Intel, with the i5 being still pretty good, but not something you choose if rendering is your thing. But just as an FYI, mate, as a side note, these Keyshot scores, they're not points, right? The Keyshot team, for reasons that are only known to them, decided to rate the scores from their test as a multiplication factor over their tested baseline system, which is ludicrously and unnecessarily complicated. So the i9 3900K is apparently 5.7 times better than the system that they used as a baseline. What's that system? Well, you have to go look for it, mate. Really hard. It's a 6-year-old 6900K. Why? Don't know. Anyway, time for a conclusion on all this, mate. So if you haven't realized by this point, I just focus on professional applications. And would you believe it? There's hardly any benchmark tools that exist for professional tests, and tests that actually mean something, which is why I ended up spending 2 years of my life making my own benchmark test to try and add something to this conversation. But there's a fair amount to unwrap here, mate, with the long and short being, if you're already on a 12900K, and you do CAD stuff, Autodesk stuff, SolidWorks and all of that. Unless you like just having the latest and the best, most up-to-date system on the market, this isn't a justifiable upgrade from a 12900K. It is, however, a very worthwhile upgrade from anything 11th gen or beyond, and that goes for the i5 as well. However, if you regularly knock out CPU generated renders, use any kind of simulation software that leverages all cores or parallel compute, and your program isn't significantly impacted by Amdahl's law or Gustafson's law, don't have time to go into that right now, but it's a thing, then this might make sense as an upgrade due to the 40% gain in all core workloads you're going to get from this 13th gen part over the 12900K. Now, of course, many might and probably will say, always do, that, hang on a minute, Neil, hang on, what are you saying that for? The AMD 7950X is near as damn it to the 3900K, and that uses far less power. Why wouldn't you just go for that instead of a 3900K? Yeah, all right, look, here's the thing. For a start, they are very close in raw performance, but the hybrid workflows that are enabled by 12th and 13th gen are exceptionally valuable. That's the whole being able to set off a large computationally expensive job and assign it to the E-cores, of which you've now got 16 of them. And I demonstrated all of this, mate, on the Biz Insight stage at Intel On in Texas when I launched the Core HX platform for mobile workstations in May. But also the 7950X, mate, as a standalone part, is actually 80 quid more expensive than a 3900K if you're putting together a DIY system, that is. And not just that, you can pick up admittedly a low-end Z690 motherboard for Intel for as low as 160 quid, whereas the AMD X670 boards, again for the absolute baseline, bottom of the range one, starts at around 280 quid. So the cost of entry here is much cheaper on Intel, roughly around £200 today as things stand, which obviously might change in the future. As for the power consumption, this is a tricky one. To some it might not be, it might just be black and white, but right, you can argue this into any direction. I was going to present some rough factual numbers here and electricity costs and all that, but I decided against it because electricity costs vary dramatically from region to region across the world. Everyone uses their systems differently as well. But what I'll say is this, right? If you're a gamer, look at the power draw on the 3900K, compare that against something like a 7950X, work out roughly how much you use your system over the course of a day, and then figure out how much extra in electricity it would roughly cost you to run a 3900K, which pulls more power. Compare that number against the 200 quid extra you'll need to buy into AMD's platform, and mate, I can guarantee it's going to be a long time before the electricity costs outweigh the initial cost of entry into AMD by buying the motherboard and the extra price of the 7950X, and that's again roughly at today's prices. If you're a business customer though, and you're buying one of these for work, mate, this is a non-issue. Even if you're running a PC at max tilt for 8 hours a day, which you won't ever be at 100% all day long, you just won't. But if you are, the electricity costs, even with today's outrageous energy prices, should not be affecting your profit and loss. If it is, you've probably got bigger problems in your cash flow, given that the computers, right, it's what you're normally using to generate your revenue with. Nobody in a business setting should be concerned about the cost to run their desktops, unless, of course, right, you're looking at this from an environmental standpoint, but that's not pricing. That's a completely different argument altogether. However, if you're buying an OEM system from a vendor like Dell or Lenovo or HP, well, this is why I tested the i9 earlier on with a smaller cooler, because obviously the tier 1 vendors don't put huge 360mm liquid coolers into their workstations. And I've seen this firsthand. I've seen some absolute monstrosities inside professional workstations. Vendors putting cheap air-based coolers, really cheap ones, on top of i9s and thinking that their brand name on the box, on the case, is going to infuse it with some sort of magical miracle juice or something that nobody's going to notice. It won't, and they do notice. What I'm getting at here is when Dell, HP, and Lenovo start pumping out their workstations fitted with i9 3900Ks in, which they will, I fully expect their performance to be way short of what we're seeing here, with huge deviation across those brands based on how well or how poor they've done the cooling. And finally, it'll be, let's just say, interesting to see what happens when the 13th gen mobile workstations start hitting the market, because the mobile workstation CPU is now Core HX. It's not Mobile Xeon anymore. In Core HX, it's the desktop i9 in a laptop. And frankly, mate, the current thermal solutions in laptops today barely coped with the 12th gen desktop part. In fact, some didn't. So adding another potential 80 to 100 watts on top of what the 12th gen i9 was pulling, mate, it's going to need some innovative thermal design and sufficient power supplies with these laptops, or else they'll end up just running these things at half the potential power draw that it's capable of in the laptop, which would completely defy the point of even having these desktop parts in a laptop in the first place. And if you're of the opinion, well, what's the point in even considering any of this when AMD are near enough, much or less the same performance as Intel with much less power draw? Well, mate, don't forget, Intel have got the hybrid workflows. Don't dismiss them. They are much underrated. I've linked a video in the description below showing what all this basically is, but it's absolutely a worthwhile factor to consider when choosing, because they're very valuable. But for now, that was the new Intel i9 3900K. Intel is back on top with caveats and many ifs and buts, but absolutely a solid upgrade from anywhere from 11th gen and below. There's much overclocking as well to be had here as well, much headroom, which we're already twice as fast as 10th gen parts with 3900K. So if you're on a 6700K, 8700K, or even 9900K, mate, you're going to get a hugely significant productivity boost when moving to 13th gen. Anyway, that'll do it for now. My name is Neil Cross. This has been Tech 3D. Thanks for watching. Don't forget, Chris, mate, subscribe if you didn't do it already. Thanks for watching, and toodles.